Hello friends, myself R.D. Mahajan presenting my one more video on bilinear transformation. Let us solve the problem. Find bilinear transformation which maps the points z1 is equals to 1, z2 is equals to I, z3 is equals to minus 1 onto the another 3 points w1 is equals to 0, w2 is equals to 1 and w3 is equals to infinity. And to obtain that bilinear transformation, we take the help of that formula using bilinear transformation formula. We have that formula is w minus w1 into w2 minus w3, order 1 2 3, and in denominator we have w minus w3 and w2 minus w1, 3 to 1, and the same type of terms on right hand side for z as z minus z1, z2 minus z3, and in denominator we have z minus z3, z2 minus z1, and then substituting the values we get, that is w minus w1, the value of w1 is 0, w2 is 1 minus w3, it is infinity, whole divided by w minus w3, it is infinity, w2 1 minus w1 0, and that is equals to z minus z1 1, z2 is I minus z3 is minus 1, minus minus it becomes plus 1, whole divided by z minus z3, minus minus it becomes plus. Next, z2 I minus z1, it is 1, and therefore rewriting that infinity a as 1 by rho, where rho is 0, therefore 1 by 0 we get infinity, and therefore replacing infinity everywhere by that 1 by rho, we get w minus 0 is w, 1 minus infinity, infinity is nothing but 1 by rho, whole divided by w minus infinity, again 1 by rho, into 1, and that is equals to z minus 1 into I plus 1 divided by z plus 1 into I minus 1. Therefore, cross multiplying by 1 by rho, but rho is 0, this term becomes 0, we get only w multiplied by 0 minus 1, we get that value as minus 1, divided by rho, rho into w, but rho is 0, this term becomes 0, minus 1 divided by rho. Rho from numerator and denominator get cancelled, and therefore we get that is equals to z minus 1 into I plus 1 whole divided by z plus 1 into I minus 1, minus and this minus get cancelled, we get w is equal. To simplify it further, we multiply and divide by the conjugate of this term 1 I minus 1, therefore its conjugate is I plus 1 and divided by I plus 1. We multiply and divide by the same number so that value does not change, only form is change. And then simplifying it further, we get that value as z minus 1, I plus 1 into I plus 1, it becomes the square of that term, that is I plus 1 whole square, whole divided by z plus 1. Here the terms are a plus b into a minus b type of term. The product of that term is a square minus b square, and therefore it becomes a square means I square minus 1 square 1. We get as z minus 1, expanding this by a plus b whole square. Its expansion is a square means I square plus twice ab 2i and plus b square 1 square 1 whole divided by, it is z plus 1 z plus 1. I square is minus 1 and this minus 1, it becomes minus 2. We get this one is z minus 1. I square is minus 1. Minus 1 plus 1 get cancelled. We have only 2i whole divided by z plus 1 into minus 2. 2 to get cancelled. We get I into multiplying by minus inside this term of numerator, we get that term as 1 minus z and divided by z plus 1 nothing but 1 plus z. Therefore, w is equals to I into 1 minus z divided by 1 plus z as the required bilinear transformation. The degree of the terms of z and w is 1, that's why it is linear, and both terms with degree 1, that's why it is bilinear. Therefore, the final transformation is w is equals to I multiplied by 1 minus z and whole divided by 1 plus z. One more I will discuss in my next video. Therefore, if you like my videos, please share it as well as subscribe to my channel to receive the notification for my such type of new videos. For that, you have to press the bell icon. Thank you. Thanks for watching.